Hello there, Mr. Sutton here, bringing you the IM3 Honors 1-3 Part 2 homework solutions on piecewise functions.
For number 9, we're given the graph of a piecewise function and asked to match the correct function with it. So for this one, it's really process of elimination. If you look at the second rule for all of the answer choices, they're all x's, so this interval here is not going to help us out much. So let's look at the first interval. That's from -4 less than or equal to x less than or equal to 0. We know those are the intervals because we've got solid dots at both of those spots. And then for the function there, it's just a line. We have a slope of -1/2. We're going down 1, right 2. Y-intercept is 0. So then that equation is just y equals -1/2 x. So that narrows it down a little bit. We can eliminate choice B and choice D, which doesn't have the correct sign. So it's down to A and C. The big difference between A and C is the intervals. With A, they don't include -4 and 0 on that rule, and with C, they do include it. Since we have solid dots, we should be including -4, so that means answer choice C is the answer. For this problem, I'm trying to graph this piecewise function. This consists of two lines, and one line stops at 2 and the other line picks up at 2. The first line goes left forever, the second line goes right forever. So really I want to figure out the x and y values where one line stops and the other line begins, the points where that's happening. To do that, for my first line, the endpoint of the first line, I'm going to plug in this border value of 2 to this first rule here. So I've got -2 times 2 plus 4. That's going to be -4 plus 4, which is 0. So that means that this first line ends at the point 2, 0. Now, because we have less than 2 and there's no equals here, the no equals is the key, that means we have an open dot for this line at 2, 0. It's just kind of an anchor point. It doesn't actually exist on the function itself. So over 2, up 0, there's our open dot. This is where our line is ending. Now we need one other dot on this line, one other point, to actually draw the line as we move to the left. We have a slope for this first line of -2. That means that I have to use that slope to get another point. Now I can't really go down 2 and right 1 because this line doesn't exist after the x value 2, but I can reverse those directions and go up 2 and left 1. And that still gives me a point of -2 as I move to the right. So I'll just draw a line through those going forever to the left. And now it's on to the next line here that I'm trying to draw. So to get the point that this line begins at, I'm going to again plug 2 in, but now I'm plugging it into the -x plus 3 rule. So I've got -2 plus 3. That's -2 plus 3 giving me 1. So that's the point 2, 1. And because we had the equals on this one, we do have a solid dot for this point. So here is 2, 1 right here, just above my open dot. This line has a slope of -1, and I can use that to get my next point. So starting at the solid dot I just drew, I'm going to go down 1, right 1, and that gives me another point to draw the second line. For problem number 3, we need to graph this piecewise function that has two lines in it. To get the first rule here, the -2x plus 8, I'm going to start by plugging in that border value of 4 to figure out where this thing ends, and then we'll kind of work backwards. So if I plug 4 into this function, that's -2 times 4 plus 8. That's going to be -8 plus 8, which is 0. So this gives us the endpoint 4, 0. Now, is this an open dot or a solid dot? Well, this rule works if x is less than or equal to 4. The equals tells us that we have a solid dot at 4, 0, right here. Now we need to come up, since this is a line, we just need one more dot, one more point, another point back somewhere over here. I think the easiest one to use on this is the y-intercept of 8. That gives us the point 0, 8, which is going to be all the way up here. And then I'll just, starting here, draw a line that goes through that, and it'll go forever to the left, but it does have to stop here because this is an endpoint. All right, let's take a look at our second case, the 1/2 x. So first off, we need to figure out where this thing begins. It begins at the same x value that the other one ends. Let's figure out the y value where it begins at. So if we plug 4 into this second rule, 1/2 times 4, that gives us 2. So that then is the point 4 comma 2. Since the function doesn't actually equal or use the x value 4, this is greater than, not greater than or equal to, we need an open dot at 4 comma 2. So we'll put the open dot up here. So this isn't actually a part of the function, it's just kind of a placeholder to anchor it there. And now for the rest of it, we need one more point. At this point, I think if we just use that slope of 1/2, we can easily get another point. So starting at our open dot, we go up 1 over 2, there's another point, and just draw the line through those. For number 4, we need to graph this piecewise function. This piecewise function has a horizontal line and a regular slanted line in it. We'll do this first case first. So we just, again, horizontal line going through -5. Let's start by getting the end point, the place where this thing ends. That's at the x value -1. If I plug in -1, I'll get back a -5. So that means my endpoint is -1 comma -5. Now, since this is less than without an equals, the no equals is important here, that means we have an open dot at -1 comma -5, because the function isn't actually defined there for this rule, but it's a placeholder. Since this is a horizontal line, we can just draw the horizontal line going backwards here. Now let's do the second rule, -3x plus 1. So for this one, we need to figure out where we're beginning, the point we're beginning at. Let's plug -1 into this rule to see the y value that goes with it. So that's -3 times -1 plus 1. 3 plus 1 then, which is 4. So we then have the point, the solid dot, because we have the equals, -1 comma 4. So -1 comma 4 all the way up here. That's a bit of a jump. And now we just need one more point over on the right side here. Easy way to do this is just to use the y-intercept of 1. You also could have used the slope of -3. They both actually end up taking you to the same point on the y-axis here at 0 comma 1. So just draw a line through those, and we're done. For number 5, we need to write a piecewise function for this step function here. So we're just going to write the constant values and the intervals that they are in as the rules for our piecewise function. Starting on the left, we've got the y value 5, and that's going to be true from 0 less than or equal to x, less than, this is 7 right here. Next one, we have 20, and that applies between 7 and 12, so 7 less than or equal to x, less than 12. And then finally, we have up here, this is 45. This is when x is greater than or equal to 12. To write a piecewise function for this step function, we're going to need 4 different rules. For the first rule, we're returning a constant value of 0 down here, and that'll be from 0 to 3, not including 3. So we're going to do 0, and then for the actual interval, 0 less than or equal to x, less than 3. Next, we've got the value 2 being returned for, let's see, 3 less than or equal to 0, less than 8. Next, we've got 5 for, let's see, this would be 8 less than or equal to x, less than, this is going to be 18. And then we've got, finally, 8. This will be for x greater than or equal to 18. For number 8, they're giving us this piecewise function, and they want to know what x values make this undefined. And we get to select all that apply, so it might be more than one of these. So to see where it's undefined, well, let's just talk about what it means to be defined. An x value is defined on here if there is either a solid dot or a solid line at that x value. So let's just go through and see where that breaks down for each of these. So for the x value 1, right here, we have an open dot, so that's going to be undefined. For -2, that is a solid line, so that's defined there. For -3, open dot, 2 open dots, either way, undefined. 1/2, that's right in here. There's actually nothing there at all, open or solid, so that counts as undefined. It's not defined for that spot. And for x equals 4, we have a solid dot down here, so that's defined. So then we're going with A, C, and D. Those are the places where we don't have something solid.